you should hopefully see my title screen, and this is again titled "A Framework for Identifying Host-Based Artifacts in Dark Web Investigations." So our lab is located on the campus of Dakota State University in Madison, South Dakota. We're a small community in eastern South Dakota. Our lab was founded in 2018 as a partnership between Dakota State University, the South Dakota Division of Criminal Investigation, and the South Dakota Attorney General's Office. We receive our funding through a variety of federal, state, and private partnerships. And our mission is to perform examinations on digital evidence that's part of a criminal investigation in the state of South Dakota. And the exception of that is that we did not do ICAC cases, which is Internet Crimes Against Children, or otherwise known as child pornography. We do every other type of exam, from drug cases to homicide to unidentified death to crash investigations, any other type of examination. We work with over 40 local, state, and federal agencies throughout the state of South Dakota. And we also conduct open source investigations for the South Dakota Attorney General's Office in support of any casework that they do upon their request. And our partnerships are really what makes our lab a success. We have a DCI special agent, Toby Russell, who is my co-director of the lab and acts as law enforcement liaison. Toby has 15 years of digital forensics experience, is an amazing wealth of knowledge, and we really couldn't do this without him. We have a great partnership and we work really well together. And we've also formed partnerships with other agencies within the state, such as the South Dakota Fusion Center, which functions under the South Dakota State Homeland Security Office. And through that partnership, we have a cyber intel analyst who is actually a DSU employee, but is stationed in the Fusion Center. And we also have a partnership with the Sioux Falls Police Department, which is the largest agency in our state. And we believe that these partnerships are the way to grow and make things better for our state. And the partnerships can be a little tricky at times, but we work through it and we feel that we are all better off. Now, DSU has been designated by the NSA as a center of academic excellence in the 3 designations of cyber research, cyber defense research, and cyber operations. And we were one of the first institutions to hold all 3 designations. Now, this framework is created as the subject of my doctoral dissertation, which I completed almost exactly a year ago, last November. I came to DSU to complete a master's degree and then ended up staying and completing a PhD. Once I finished the master's degree, what I really had left was just some research classes and a dissertation. And I thought, well, how hard can that be? A dissertation is just a big long paper, which it turns out it's a little harder than that, but I got through it, and the framework was the result of that research. And the original idea for the framework came when I started early on doing casework. As I was learning, I thought it'd be really helpful to have a guide or high-level idea of what artifacts you would find or what you would first look at for each different type of case you were doing. So for example, if you're looking at a drug case, you're going to look at communications, you're going to look at images, you're going to look at web history. And if you're doing a fraud case, you'd look at documents, you'd look at images, communications, that type of thing. Well, that was a little too broad for a dissertation topic. And around that same time, we happened to take in a couple of drug cases where the drugs were being purchased on the dark web. So it was then that it was narrowed down to dark web artifacts. Now, the goal of the dark web is privacy and anonymity, which then lends itself to criminal activity. And these same privacy and anonymity settings of the browser also makes host-based artifacts difficult to find and recognize. And I chose the dark web as a topic for a couple of reasons. One, you need to choose a topic that you don't mind focusing on for a long period of time. And I really found the dark web just fascinating. And another reason was because I'd always heard that it leaves little or no trace behind. And I thought, how can that be? And is that really the case? And so I set out to find out. So what exactly is the dark web? Now, to understand the dark web, let's first talk about the World Wide Web. World Wide Web is a system that uses the infrastructure of the internet, and it's just a means of retrieving information. It can be separated into 3 main areas: the surface web, the deep web, and the dark web. You'll hear the terms deep web and dark web thrown around interchangeably, but they are not the same thing. So first we have the surface web, which is also known as the visible web, the indexed web, or the clear net. Anyone can access it. In search engines like Google, Bing, Yahoo, or other search engines use their technology to find the pages to display. So think of anything you can Google, and then all the results that come back when you Google something. So, and also the site names end in things like .com, .net, .edu, .gov. So my examples up here, msn.com, sd.gov, dsu.edu. And to reach sites on the surface web, use a standard browser such as Chrome, Edge, Internet Explorer, Safari, or whatever your favorite browser of choice is. And the surface web contains billions and billions of pages, but it's really just a very small part of the World Wide Web. It really is just the tip of the iceberg. Now, below the surface web is the deep web. These are the things you can't Google because they're not indexed by search engines, but they are reachable with the proper access. You either have the right link or the right login credentials. So a good example is what's stored on the deep web is your bank account. You can reach it, you can access it, but you can't Google it. So you think of your bank, you can Google your bank name, like US Bank, to find their site. That's in the clear web, but you can't access your specific account unless you use your login credentials. Your account is in the deep web. Medical records, student records, cloud data, company databases, it's all out there. You can access it with the right credentials or link. You just can't Google it. Things that are behind a paywall are also good examples of what's stored in the deep web. Netflix or other subscription services store their content in the deep web. A real world analogy I like to use is if you're walking down the hallway in a hotel or an apartment building, the hallway is like the surface web. Anyone can walk through there, but to enter one of the rooms, you have to have a key. So that would be like being in the deep web. Then we have the dark web, which is really just a very small part of the deep web. The lifespan of these sites is very short and they change frequently. The dark web uses the same infrastructure, but it can't be accessed with regular browsers such as Chrome, Edge, or Safari. And there's more than one dark web depending on how you access it, with the most common of those being Tor, which is what we're going to talk about today. Although there are others such as Freenet, I2P, and ZeroNet. And collectively, these are known as cypherspace. The other thing that's unique about the dark web are that the site names are URLs. We're used to sites that end in .com, .net, .edu, .gov, like I mentioned earlier, but dark web sites on the Tor network end in .onion, and I'll explain that in a few minutes. And they also don't use easily memorable site names like Amazon.com or Facebook.com, but rather they have URLs that are 56 alphanumeric characters, and so they're very long, and they're also both letters and numbers, like I said, alphanumeric. So they're not super easy to type in or to memorize. So here's just an overall picture of the surface web, the deep web, and the dark web. And this iceberg image gets used a lot to explain all three, but it's really just a very good illustration of what it looks like. So the most common way to access the dark web is using Tor. And Tor is an acronym for the onion router. Now, normally when you connect to a website, it shows the user's IP address so you can find the location. Tor was developed by the US Naval Research Lab as a way for military personnel stationed overseas to communicate securely so their IP address wouldn't be revealed and pinpoint their location. And Tor is made up of a network of volunteer servers. When information on the internet is sent, it's sent in packets. But when Tor sends a packet, it first wraps it in 3 layers of encryption, then passes the packet through 3 relays or nodes before it reaches the site it's connecting to. Each of these relays only knows the node it came from and the next one it's going to. It doesn't know the full path from beginning to end. So when a packet's sent, it goes to the first node where the first layer of encryption is removed. It then goes to the second node where the second layer of encryption gets removed. And finally, to the last node, which is called the exit node, which removes the third layer of encryption. At the exit node, the packet's fully decrypted before being sent to the final destination. And it's this layering is how it got the name the onion router. Removing the encryption layers is like peeling an onion. And it's also this layering that makes tracing very difficult. Tor can be installed on a variety of operating systems, including Windows, macOS, Linux, Android, and standalone options like Tails or a virtual machine such as Unix. An example of a standalone system is Tails. The Tails stands for the Amnesic Incognito Live System. It's bootable from either a DVD or a USB drive, and it's its own self-contained operating system. Tails comes with Tor pre-installed, and it also includes other tools such as encrypted messaging, email, open source Office software, anonymous file sharing, encryption tools, a password manager, and other tools like an image editor and a DVD burner. So what can we find out on the dark web? While there are sites that are benign, much of the dark web consists of nefarious and illegal content. Financial services such as stolen credit cards, PayPal accounts, bank accounts, fake IDs, fake passports, counterfeit money, counterfeit gift cards, malware and other hacking tools. You don't have to know how to create malware, you can just go buy it on the dark web. Drugs of any kind you can imagine, weapons such as assault rifles and grenade launchers, and these are untraceable, whether they don't have serial numbers on them. Stolen credentials from data breaches, pornography of all types, including the illegal kind, and how-to manuals for all of the above. So if you don't know how to do something, you can just buy a manual of how to do it. In addition to all of that, if that weren't enough, there's uncensored, unfiltered, and anonymous forums where users can connect with other like-minded individuals. Now, one way this criminal activity manifests itself in the dark web is in marketplaces, where the content I mentioned earlier is bought and sold. So think eBay or Craigslist, only for criminals. One of the first big marketplaces was the Silk Road, which was shut down in 2013 during Operation Anonymous. Many more marketplaces have come and gone, either by being shut down or closed in an exit scam, such as Empire Market not too long ago. However, there's many other markets currently operating. After Operation Anonymous that shut down Silk Road, there's been many more marketplace shutdowns. The question I often get asked is, well, why don't they just shut them down? Well, they do. It averages about once a year, but when one marketplace shuts down, others pop up in their place. In January of this year, Dark Market was taken down, and just a few weeks ago, Operation Dark Hunter, which was a coordinated international effort on 3 continents to disrupt opioid trafficking. Operation Dark Hunter resulted in the seizure of over 31.6 million in both cash and virtual currencies. It was approximately 234 kilos of drugs worldwide, including 152 kilos of amphetamine, 21 kilos of cocaine, 26 kilos of opioids, 32 kilos of MDMA. In addition, more than 200,000 ecstasy, fentanyl, oxy, hydrocodone, and methamphetamine pills, and counterfeit medicine, 45 firearms, and it was a 10-month collaborative investigation. In addition to that, Italian authorities also shut down 2 local dark web marketplaces called Deep Sea and Berlusconi Market. Yet despite all of these operations and arrests, several of these dark web market sites continue to operate. So you can see these market shutdowns average about once a year. And this is just a headline that shows that these marketplace or these dark web drugs are being bought and sold all over the place, even in our small state of South Dakota. South Dakota is a very rural state, but we even are affected by it here. And this was a case that we actually handled in our lab right here that saw some residents that were sentenced for buying meth on the dark web. So we were required to pick a methodology, and we're given in order for my dissertation, and we're given examples such as quantitative, which would be numbers-based, qualitative, which are concepts, experiences, or opinions, and design science. And I use design science methodology because it identifies a question to be answered with the creation of an artifact to solve a problem. And so I actually got to create something in the artifact instead of just writing a big long paper. Well, I still actually wrote a big long paper, but I had something, a thing to actually show for it. So design science has quite a few steps to follow to show its legitimacy. I'm not going to go into all of those, but a few to explain how this framework came about. So some of the steps include identifying a problem through the question, establishing the goals, and then setting the requirements. So for what I was doing, the question I asked was, what host-based artifacts can be identified on a system that's running either Windows PC or macOS when the user's been accessing the dark web? And then my follow-up questions to help answer that main question were, what methods or tools are used to remain anonymous when accessing the dark web? What additional steps are users taking to further obfuscate their dark web activity? What traces of Tor remain in the Windows registry after use? Can sites that were visited while using Tor be identified? And if a system is booted with a Tails USB drive that supposedly leaves no trace, will any traces of having booted to that USB remain on the system? So the goals of my project were to create a reusable framework to assist digital forensic analysts in acquiring host-based artifacts when conducting computer forensic investigations involving suspected dark web criminal activity. And it must be reusable, something to be used over and over again, rather than having to print it out and use up a whole bunch of paper or have to follow on a page. And then for the requirements that needed to be established, number one, it has to be easy. It had to be easy for investigators to follow, so as it didn't inhibit their investigation by requiring more effort on their part to use it than what was gained in usable evidence. It had to consider both Windows and macOS operating systems. On a single case here in our lab, we can get multiple pieces of digital evidence. So it's not unusual to get both Windows and macOS. And as Windows and macOS are the most common desktop operating systems, I wanted to consider both of them. Also wanted to consider multiple ways to access the dark web using Tor. Tor can be installed on a hard drive, run from a flash drive, or run as part of a bootable Tails operating system. All three methods of access need to be explored. And it also had to be adaptable to future platforms. To keep my research narrow, I focused on Windows and Mac and didn't look at mobile, although I would have liked to. And I'll talk about that a little bit later, but it's something that I would like to add to the framework and have actually started working on. And then another step that's required of design science that I didn't mention is to identify any stakeholders in the research, anyone who would benefit from that research. And maybe some of you listening today might be able to benefit from this. And I chose Tor and Tails as the two access methods for my research. Both Tor and Tails are aimed at privacy and anonymity. And there's three main steps that were taken between each step. The system I was using was completely reset to the factory settings and verified. So number one, I booted into Tails. And again, it's bootable either from a DVD or USB drive. And I used a USB drive. And they state that it uses RAM, but that it erases that memory when the computer powers down. Now, Tails comes with Tor installed and all those other tools that I mentioned earlier. So I booted into Tails, generated a whole bunch of dark web activity, and then used some of those tools that were mentioned. Well, Tails has an option for persistent storage. So if the user doesn't set up persistent storage, then no artifacts are indeed saved. So for my research, I did set up the persistent storage and then set the super secret password of password 1. I did this on both macOS and Windows. And then after booting into Tails and restarting, I imaged both the hard drive and the Tails drive. And we've actually had a couple of cases here in our lab of users using a Tails drive. I had one young man from a small town here in South Dakota that had been purchasing his drugs on the dark web. And first they were using a computer, and they ended up selling the computer to have more money to buy drugs. And so then he was using a Tails drive, and I was sitting in on the interview with the investigators, and I asked him, where did you get your Tails drive? Did you make it? Where did you get it? And he had purchased it off of eBay. So that was interesting that you can just go out to eBay and buy a Tails drive. They're about $15. So that was the steps I took for Tails. Then the next step was booting into the operating system, either Windows or macOS, and then launching Tor from a USB drive or an SD card. And in that step, I did a memory capture prior to powering down the machine, and then imaged the hard drive after the machine had been turned off. And then the third step was booting into the operating system and opening Tor after it had been installed on the hard drive itself. So with that, as with launching from the USB drive, I did a memory capture prior to powering down the machine and then imaged the hard drive. I then removed Tor and imaged the hard drive again to see what was left behind and added that to the framework. And an interesting thing to note about Tor, whether you're using macOS or Windows, there is no uninstall option for Tor. On Windows, you simply drag it to the recycle bin, and on macOS, you find it in the applications folder and drag it to the trash. And so if the user is sloppy and doesn't empty their trash bin, you're going to find more artifacts. You're still going to find artifacts either way, but you find more if they have forgotten to empty that recycle bin. Now, the tools that I used included FTK Imager, Macquisition, RAM Capture, FTK, and Magnet Axiom. The framework was created using the open source OSINT framework by Justin Nordin as a guide. And some of you may or may not be familiar with Justin's framework if you've visited his site. And I was familiar with Justin's tool and thought it was really interesting and helpful open source tool, and it would be adaptable to what I was trying to accomplish. It was easy to follow, and it was reusable. And for me, I'm not a great programmer. I can follow along, but not necessarily create something from scratch. So for me, it was a perfect solution. And so now I will share with you my framework. Just have to get to it. And that is the link. Okay, so hopefully you now see my main screen with my framework. And this is how it opens up. You should say Dark Web Artifact Framework. And it opens up and you see Windows PC, Mac OS, and then Tails USB. Each one of these dots, if it's a white dot, it's open as far as it'll go. And if it's a blue dot, then it can open yet further from where it is. So I'm going to start with Windows. And when you click on it, so with Windows, there's a choice. Is Tor installed locally, or was it run from a USB drive? Well, let's say it was installed locally. I'm going to click on that because it's blue. Well, then we have more options. Is Tor uninstalled, or is it still installed? And I apologize. My headphones just died. Can you still hear me? Hopefully. Are you able to hear me? Okay, I'm going to assume you can unless I hear otherwise. Okay, so let's say Tor is still installed. Then it opens up to all these artifacts. So we have the launch location. We have Tor browser install browser artifacts. We have the .onion sites. We have a memory capture. We have registry files, downloaded images, and timeline activity. So if we want to know where the launch location is, we're going to click on that, and there's even more artifacts. And these are all the artifacts you're going to find that have indications, that may have indications of where Tor was launched from, if it's been still installed and installed locally. So this first one is the System Resource Usage Monitor, or we may have link files. We may have Windows Defender logs. We may have registry files. We may have Windows event logs. We may have prefetch files or Windows NTFS log files. And again, these are blue, so they open up even further. And these don't necessarily mean you definitely will find artifacts, but you may find them. So I'm going to select the prefetch files. If you're in forensics, you may or should know what prefetch files are. So we're going to click on that. And this leads out to a white dot. So this is the end of the line for this particular artifact. And it's saying you should find an artifact in Windows, prefetch, and then the Firefox.exe prefetch file. Well, let's say we're brand new and we don't know what that artifact is. You can then click on this link, and it's going to take you to more information that's going to tell you, well, what is a prefetch file? Well, here's an article that's going to tell you what that's all about. And it's going to give you some helpful information. So each one of these end links on the framework, when you get to the end, is going to give you a link to open source information that explains what that artifact is. Let's try this one and make sure it works. Yep, here's a SANS paper on Windows event logging. And it leaves those windows open, and we can go back. Well, let's look at the NTFS files. And again, another article on what that particular artifact is going to tell you. Okay. When we've got all these windows open, well, we want to start over again. I'm just going to refresh. And it takes us back to where we started. Okay, let's look at macOS briefly. This is very similar to the Windows, if you remember. It gives you two options: Tor is installed locally, or Tor is run from a USB or an SD card. Well, let's look at the USB on this one. Well, we have an image, what artifacts we might find on the hard drive image. We have the artifacts we might find on the USB or the SD card. And then we have what we might find in the memory capture. Well, let's look at the hard drive. We're going to find the Tor browser data and the user info. We're going to find the USB drive remnants and the downloaded images. Well, and here's the information on the USB drive. Well, let's look at the USB drive. We're going to find bookmarks. If they bookmark thing, it's going to give you information in the places.sqlite file. You might find Firefox add-ons, and we might find Tor, where the Tor files were installed. So all those artifacts that you might be able to find if Tor is run from a USB drive. And again, each one of these you're going to be able to click on, and it's going to take you out to another link. The Tails drive is a little bit different than the Windows and the macOS in that it walks you through how to find the information on the drive. So with the Tails USB, the first thing it's going to do is asking it to image it with using FTK Imager. Well, let's say you don't have FTK Imager. Again, it's a white dot, so we can click on it, and it's going to take us to a link. It takes us to the Access Data site, who makes FTK Imager, and there's the download for FTK Imager. So we'll do that first, and then, whoopsie. The first question is, does it contain encrypted storage? And that would be a Tails data partition. Okay, so first, does it contain that? Yes, it's blue. If it doesn't, then there's no further place to go. We're just done. You have to stop. Well, let's say it does. It does. So then we're going to say we're going to export that as a raw image from FTK Imager. And then we're going to copy that image, which is a .001 file, to a Linux machine. And now I think you could probably use a virtual machine. I did not do that as part of my research because I had a Linux machine, but I think you could probably do that. I just haven't tested it. So once it's copied, then the next question is, do you know the password? It's surprising how many times when these machines are taken during a search warrant that they have their password written down in a journal next to their machine. So that's actually a fair question that you do know the password. Surprisingly, we do know the password quite often. So the question is, do we know the password, yes or no? Let's say we don't. We don't know the password. Well, then we're going to use Hashcat or some other password cracking tool to attempt to crack that password. Well, then did we find the password? If we did, we're going to jump back up here to the password known, yes. And if we didn't, then we have to stop again because we can't really go any further. It's encrypted and we're just stuck. Until we crack that password or find out what it is, we can't go any further. Well, let's say we did get the password. We're going to close that and jump up here to yes. We're going to decrypt, we're going to mount, we're going to copy, and then we're going to re-image that image. So you're going to decrypt it and export the partition with crypt setup. Well, again, if we don't know how to do that, we click on it. And here's a step-by-step on how to do all those things. There's Hashcat, there's how to export the encrypted partition, and all the step-by-step on how to do exactly what I was just explaining. It tells how to mount it, how to copy it, and then you're imaging it with FTK Imager, at which point you're going to skip to this next step. You can close that. And here's what you're going to find once you, or what you may find if you process it with FTK Imager. You might find bookmarks. And generally we do find that because when they create that encrypted storage, they assume it's safe. So they feel that they can go ahead and bookmark sites because with those very long URLs, they're hard to remember. They don't want to have to type in 56 characters every single time. So they'll go ahead and bookmark their favorite marketplaces. So you'll find bookmarks. You might find the system connections, the Wi-Fi connections, which does include the SSID and the password of the Wi-Fi. You might find the pigeon logs, which are internet chat files. You might find email, and then their stored passwords. So that's what you find with those Tails USB. If it has the encrypted storage, that really is a wealth of data. And if it doesn't, you're not going to find anything at all, unfortunately. So switch it back here. Switch my screen. Oops. I apologize, I didn't have my framework up. So there's the framework. And I'm happy to share that. If anyone has any questions when I'm done, I'm happy to share that framework. The framework is out there. It's not, the code is not open source, but the framework is out there for anyone to use. Now, the limitations on my research were that it's Tor only for the dark web. I did not look at I2P or Freenet. I did not look at other methods of accessing the dark web, such as Linux, Unix, Cubes, Android, or iOS. Now, iOS, there is no specific app from the Tor project for iOS. There are several apps out there for iOS. They just don't come from the Tor project. But those are things that I would like to add for future work, is any mobile forensics. Then another limitation is that it's not network forensics. It's host-based only, so anything that resides on the host system, so on the hard drive of the system or device. And then again, like I mentioned, the future work would be mobile. In our lab, we take in about 80% of our casework is mobile devices, or are mobile devices. We do still do computer forensics, but everything is shifting toward mobile. So that is something that I would like to continue to work on and continue to add to the framework. And with that, I'd like to thank you for your time.